In the area of science and gigantic mysteries, the subject of what existed previously, the gigantic explosion, has blended conversations and intrigued characters for quite a while. This huge request doesn't just test how we could decipher the universe. It challenges the genuine furthest reaches of human data. Envision standing at the edge of existence, looking into the colossal shadowiness and pondering what lay there before our universe was imagined. The event of the Big Bang marked the beginning of time, space, and all that we know. Anyway, was there a second earlier, previously this? Could there have been a condition of nothingness, a calm before the gaudy gathering started? And if this is true, was it, or perhaps there was something much more alarming that existed previously, before time itself? As we jump further into this question, science takes us on a journey past the universe's beginning point into thoughts that challenge our consciousness. Physicist Brian Cox, known for his investigation into the wonders of the universe, suggests that something surprising might have existed before the enormous detonation. He moves us to reconsider our thought of reality and existence. In this examination, we'll dissect the science, the speculation, and the dazzling insider secrets that might make sense of what existed preceding all that. We'll explore thoughts like self-important development, quantum changes, dark energy, and even multiverses. The answers we've revealed might just paralyze you, yet they could likewise open new understandings of our position in the universe. Get ready to jump deep into a world beyond imagination and science, where the obscure still winds around the shadows, leaving scientists floored and, sometimes, even upset. We ought to explore what existed before the Big Bang and why these theories challenge all that we thought we knew. To appreciate what may have existed before the Big Bang, we first need to painstakingly analyze what the Big Bang truly was. The Big Bang, as scientists define it, refers to the moment when the universe became extremely hot and dense, growing rapidly to set off the development of all matter, energy, and boundless forces. When we look toward the night sky, we see proof of this hot beginning, with galaxies spreading out this way and that from an early stage point. However, for what reason did this happen? Furthermore, was there a period before this thick, hot start? As indicated by the theory of enormous expansion, there was without a doubt a previously, and it was not even close to void or peaceful. Vast expansion suggests that, before the Big Bang, the universe was in a state that was cold, vacant, and loose, essentially like an immense vacuum. Anyway, this vacuum wasn't entirely unfilled. It contained a gigantic amount of energy that fueled the quick extension of space itself. This extension, called inflation, happened so rapidly that it basically established the groundwork for all that would continue in a part of a subsequent space extended at unfathomable rates, until the extension slowed down, and the energy changed into matter, particles, and the forces we see as the Big Bang. But what was the nature of this energy? For what reason did it suddenly grow the universe, and why did it stop? Specialists believe that this inestimable expansion made patches of the universe, each experiencing its own Big Bang. Imagine a fabric extending endlessly, with minuscule air pockets forming here and there, each air pocket representing a universe, including our own. This thought, called the inflationary multiverse, suggests that there are possibly limitless Big Bangs and an infinite number of universes. Our own is just one of many. This huge, mind-bending reality challenges our understanding of the very universe itself and leaves us with the question: what else is out there? The idea of nothingness before the Big Bang is speculative, not real at any rate, as per our current understanding. Regardless of whether you eliminated all energy, particles, and radiation from the universe, it would still not be genuinely void. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave an inevitable embroidered artwork of something, even in its most vacant structure. Regardless of whether we imagine stripping away all of these forces, leaving a dead space, the universe would still generate new kinds of energy. This reality alone is bewildering to specialists, as it suggests that true nothingness might be impossible. Within our infinite comprehension, space itself has properties, rules, and constants that prevent it from being totally empty. Imagine creating a region with literally nothing in it. No particles, no radiation, and no energy, except quantum fields and major constants. These would still exist, suggesting that this nothingness has properties. For instance, there's a peculiarity called zero-point energy, which represents the least possible energy condition of quantum fields. In this state, particles can still momentarily appear and evaporate, making a spooky resonance of movement, even in what should be empty space. This challenges our idea of a real void and suggests that yes, even before the Big Bang, there was something that scientists are only beginning to understand. One of the most astounding theories in current cosmology is the chance of timeless expansion. If inflation could cause our universe to exist, it's possible it could continue forever. Brian Cox describes an astonishingly vast inflationary multiverse, where universes are infinitely created and continue expanding. Imagine each Big Bang as a flash lighting another universe, while inflation continues in different areas, making countless other universes. This cycle could, in theory, go on for eternity. This idea of vast universes gives birth to an enchanting concept of a fractal universe, where each new universe might actually make its own Big Bang. Every universe exists as a separate, independent domain, unaffected by the others because of the rapid expansion of space. For researchers, this hypothesis is both exciting and upsetting, as it suggests a never-ending multiverse with no definitive beginning or end. Imagine our universe being just one bit in a giant cosmic structure, forever expanding and constantly making new universes. And what if the disturbing reality is that there is no before or after, but rather a timeless pattern of universes forming and decaying? How we may interpret nothingness changes when we consider quantum field theory. According to this theory, the universe is not just an assortment of matter floating in space. Rather, it's a complex network of energy fields that fill the universe, connecting to create all that we observe. These fields are like invisible seas, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields, momentarily acquiring energy before returning it. This phenomenon results in virtual particles, substances that immediately exist and then vanish, leaving only a faint memory of their presence. The concept of virtual particles challenges the idea of a real void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have total nothingness? According to quantum field theory, you wouldn't, even in a vacuum. Fields would remain active, sometimes creating transient particles. This constant movement in what should be nothing suggests that the universe doesn't recognize our concept of emptiness. The fields and forces endure, filling the universe with a hidden energy that prevents absolute nothingness. This understanding raises an intriguing question. If fields make particles and particles make matter, could the universe itself have emerged from this nothingness, filled with quantum fields? Dark energy is a mysterious force that currently drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? From certain perspectives, the fact that dark energy exists today is a leftover of an energy field from before our universe's development. The properties of dark energy seem to suggest a colossal hidden force that might have existed in some form prior to the Big Bang. Some theories suggest that dark energy, in a much stronger state, could have controlled the inflationary stage, causing rapid expansion. The presence of dark energy suggests that, regardless of whether our universe were exhausted of all matter and radiation, this force would continue to expand the fabric of spacetime. This thought leads to an upsetting question. If dark energy was present before the Big Bang, could it have formed the circumstances that led to the birth of our universe? Could dark energy be the silent architect of inflation, or even the true beginning of our universe? As we explore this possibility, we face the potential of dark energy not just as a force shaping our universe, but as a key that could unlock the secrets of the multiverse itself. Another theory that offers an alternative to the Big Bang as the ultimate beginning is cyclic cosmology, that the universe goes through endless cycles of birth, death, and resurrection. In this model, the Big Bang is not a one-time event, but rather part of a timeless rhythm where universes expand, collapse, and then regenerate in another cycle. This theory suggests that our universe might have been reborn from the remnants of a past universe. The process of contraction and expansion in a cyclic pattern would mean that there was never a true beginning, but rather an eternal series of universes emerging, growing, and renewing themselves over and over again. Cyclic cosmology raises significant questions about time, as it suggests that time itself might be cyclical, rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was just another version of the universe, one that collapsed only to give birth to our current universe. For researchers, this theory offers a rich answer to the question of ultimate origins, proposing that there is no true beginning. The universe has always existed in some form, transcending our ideas of time and existence. Early-stage gravitational waves are another intriguing idea that could hold clues to what existed before the Big Bang. Gravitational waves are ripples in space-time caused by massive cosmic events, and scientists believe early-stage waves, if ever detected, could reveal insights into the universe's earliest moments. These waves could serve as the echoes of what came before the Big Bang. Should they be identified, they might provide proof of the universe's previous states. The potential discovery of early-stage gravitational waves would be a groundbreaking breakthrough in our understanding of the universe's origins. These waves could carry information about the conditions that existed before the Big Bang, offering a glimpse into the fabric of space-time itself. If we could detect these waves, they might reveal evidence of the energy fluctuations, quantum states, and other phenomena that predated the formation of our current universe. The detection of such waves would provide the first real observational evidence of events occurring in the incredibly short time just after the Big Bang, during the inflationary period. Since these waves are theorized to have been generated during the rapid expansion of the early universe, finding them would confirm many of the predictions made by cosmological models. This discovery could potentially answer some of the deepest questions about the nature of time, space, and the universe itself. Moreover, understanding these gravitational waves might help us explore the concept of eternal inflation. This theory suggests that while our observable universe began with the Big Bang, the process of inflation continues in regions far beyond our reach, giving rise to an infinite number of parallel universes, or pocket universes, each with its own distinct properties. These universes could follow different physical laws or have different dimensions, and the discovery of gravitational waves might provide indirect evidence of their existence. In the grand scheme of things, such findings would point toward an even bigger realization, that the boundaries of our universe are far more fluid and expansive than we ever imagined. We might begin to see our universe as just one chapter in a never-ending saga of creation and destruction, an eternal cycle of birth, death, and rebirth, where each universe follows its own path, influenced by factors we are still trying to understand. As we venture deeper into these speculative territories, we must also consider the philosophical implications of what it means to think about the before the Big Bang. Could our conventional understanding of time, space, and causality be inadequate in explaining the nature of the universe? Some theories even propose that time itself may not have had a definite beginning. Perhaps time, like space, is a property that came into being only with the creation of the universe, and before that, there was no before, a concept that is irrelevant outside the framework of the universe. This idea challenges everything we know about reality, and forces us to think of existence in ways that stretch our imagination. The idea of no beginning and no end, or an infinite number of universes existing simultaneously, pushes the limits of human understanding. We might find that our traditional definitions of reality, of what it means to exist, may no longer hold in the face of such incredible revelations. In conclusion, the mystery of what existed before the Big Bang is more than just a scientific puzzle. It's a profound question that touches on the very nature of reality itself. Whether we are talking about a pre-Big Bang vacuum state, the existence of quantum fields, or the possibility of an infinite multiverse, these ideas challenge our most basic assumptions about time, space, and existence. While we may never fully understand what came before the Big Bang, the journey to answer this question continues to drive scientific discovery and philosophical debate. The more we uncover about the origins of the universe, the more we realize that our understanding of reality is still in its infancy. But one thing is certain. The search for answers will continue, expanding the horizons of human knowledge and opening new doors to the mysteries of the cosmos. The universe may have begun with a bang, but the questions surrounding its origins will echo throughout eternity.